Okay, so we are in Statistical Rethinking, second edition. We are in Chapter 9, and we're all the way in the hard questions, and we're on question 9H3. Okay, so this the question kind of spans all of this, and so I'll just kind of paraphrase what's going on. But we are going to revisit and then modify a model that we saw back in Chapter 6, where we were modeling height as a function, or at least the mean of height, as a function of left leg length and right leg length. Okay, and this model was set up to demonstrate a problem that can sometimes happen in regression called multilinearity or collinearity. And what that is, so if you don't remember, you should go back to chapter 3 and read about it. But basically what happens is that when you have highly correlated predictor variables, they duplicate a lot of the same information that is, informing the regression. And so what this leads to is very uncertain estimates of their respective coefficients. Okay, so the duplication of a lot of information leads to highly uncertain coefficient estimates. Okay, so now the way that we're going to modify this model in this question is to add a constraint. Okay, so here's the model that we have ran, and we'll look at that, and we are going to modify it by just adding this little argument here in the ulam code. Okay, so we add a constraint, and we are adding a constraint such that our model will only entertain guesses or estimates of BR, which again is the coefficient for the effect of the right, or I shouldn't say the effect, but the association of right leg length with height. And it's only going to consider values 0 or above, so no negative relationships. Okay, so so we're going to look at the implications of that constraint. Okay, so before doing that, make sure that you have installed and loaded the Stan and the rethinking package and all of that, and so you can do that with these code blocks up here. If you've already done this once in your own Colab sheet, if you have these programs already installed on your machine, you don't have to go through this every time, and that's how you should do it. You probably shouldn't do this on Colab, but if you're doing this on Colab, you'll get an error on this particular block. Just let it run. When you get the error, just continue down through the rest of the blocks here. Okay, so let's see, where are we at? Sorry about that. Okay, so first I'm going to just copy and paste the code presented back in chapter 6, where we're just generating the data on which we will run these regressions, and this is that code here. And for whatever reason, I had to reinstall rstan here when I was running this. So that's what this is about, to make the code below this run. So I don't know if everybody will encounter that problem, but I had to do that here in this Colab sheet. Okay. So what do we have here? We have height, and then here we are setting up the length of the legs as a function of height, even though the way our regression would maybe lead us to think about this is that we've set up height as a function of leg length. Okay, but that's no big deal. Okay, so first I'm going to run the model that we've already ran, but now we're running it in ulam instead of quap. Okay, so this is the model that was printed in the question, and to make this run I had to eliminate this start list here. So I'm not sure exactly why, but I had to get rid of it, otherwise the model wouldn't run. I just continued to get errors. So anyway, so I've already ran this so that we don't have to sit here and watch it churn, and that's fine. Now we will just go to the second model, and the second model is only different again in that we have added this constraint. Okay, that as we've already discussed. Okay, so I've ran that, and let's cut through everything. Okay, so let's see what happens with this constraint. What was the consequence of adding this constraint? Okay, so here I am plotting the Précis output. Okay, so I have my parameters here, and then the estimates given by the dot and lines. Okay, and this top plot is the first model, and the second plot is the second model. Okay, and so there's just a couple of things to notice here, and we'll talk about these as we go along. But the first thing to notice is that the error bars seem to have shrunk for the coefficients, for the BL and BR coefficients. Okay. Now, in the case of BR, this should make sense immediately. We have eliminated values below 0 as being possible values, right? And so since we are telling our model, don't even entertain values below 0, it doesn't have to account for those, and so there is less uncertainty in BR. Okay, but there also seems to be less uncertainty for BL, and so the question is, why is there less uncertainty for BL? Well, this is part of the collinearity effect. Because BR and BL are so similar, the constraint that we're placing on BR is being somewhat communicated to BL just simply by virtue of the strong relationship between BR and BL. Okay, so that's, I guess, interesting. The other thing that is maybe interesting, but it might just be pseudo-interesting, is that the mean of the estimates straddle both sides of 0 here. And I think that's probably what we should expect, that again with the high correlation between these two. And so if one of them has a positive relationship with height, the other one might have a mean negative relationship with height. Again, because that information is being duplicated, or so highly duplicated between the two variables. Okay. Now, okay, so that's one way that we can look at all of these things. Okay, but let's visualize it as we visualized it back in chapter 6, looking at the correlation between the two coefficients. Okay, as well as the entire posterior density. Okay, so just a little bit more of a detailed view. Okay, so that's what I'm going to do with this code right here. So I'm extracting samples from the posterior from each model. And then I'm going to set up a panel plot here. And so for each model, so this covers the first model and this covers the second model. So I'm going to have two plots here. Okay. So the first plot, I'm going to plot BR against BL, or BL against BR. I can't remember which, but it kind of doesn't matter. Okay. So this will essentially display the correlation between the two, more or less. And then I'm going to look at their posterior densities. Okay, and I do that for both models. All right, and so this is what I get. Let's expand this a little bit. Okay. Okay, so for the first one, for the first model, so these are the two plots for the first model. Okay, so we see again this perfect negative relationship. You know, negatively correlated by -1, or correlated by a coefficient of -1. Okay. And then here's the posterior densities. So the red line I think is BL, and the black one is BR, but it kind of doesn't matter here. Okay, and so we see that they're more or less more or less mirror images of one another. You know, but maybe even more importantly is that they are these symmetric distributions. Now if we go to the second model, again I've plotted I've plotted one as a function of the other here, but the straight line indicates the strong negative correlation. But notice what has happened to these data points in relation to the 0 points, right? We've made it so that BR cannot go below 0, and so the entire graph has shifted, right? So here's the intersection of 0, 0, and both parameters in the first model are capable of going above and below 0. And now here, we've made it so that BR cannot go below 0. Okay, so we have the same relationship, but we've just simply shifted, shifted the location of where we would plot them. Okay, and again we see that we have our two distributions that are basically mirror images of one another, which is kind of satisfying to look at. But they're no longer symmetrical, right? So the BR stacks up here around 0, right? Because it's not entertaining values below 0. Okay, and its mirror image is BL, but BL had no constraint, and so it can kind of easily traverse, both sides of 0 here. Okay, anyway. So I guess that is all that we need to show here. Okay.